Good morning, all, and thank you for joining us on this technical question and answer session, all around Always On VPN. We have technical members from Kemp, Fortem, and Celestix to answer questions, and we will just quickly introduce ourselves. So my name is Sam Lambert. I am the Senior Partner Manager for Kemp Technologies. Over to you, Lee.
I'm Lee Zandrowski. I'm the Technical Account Director for Fortem IT.
Hi, everyone. I'm Sid Bloodsaw. I'm Channel Pre-Sales at Kemp.
Hi, everyone. My name is Majid. I am the Senior Cybersecurity Technical Consultant for Celestix Networks.
Great stuff. Thanks very much, guys. Today, I'll be the question master, so I will be asking the questions, you lucky people. So without any further ado, these are the questions that have been submitted by the attendees. So let's get these questions answered, and hopefully we can start working together. Right, 2 seconds. So question 1. What are the advantages and disadvantages of hosting Always On VPN servers on-premise or in Azure? Majid, I believe you would pick this one up.
Yes, thanks for the question. Right, so we can break it down into advantages for deploying the RAS in Azure first, and then we will talk about disadvantages, and we will do the same for on-premise as well. So when it comes to deploying a RAS, which is routing and remote access service feature available within the Windows Server platform, the first thing is in Azure it is cost effective for a lot of organizations. There is no upfront cost. You can have a pay as you go or a monthly basis. Also, it provides access to the resources, workloads which have been migrated, because a lot of people are now migrating their workloads to Azure. So that is a very suitable use case for deploying the VPN service within the cloud. And as a best recommendation for deploying the VPN, it should be deployed closest to the resources, so that it can provide better user experience. With Azure having something, a virtual machine running in Azure, it provides you all the features like high availability and redundancy. You can have Azure can start a virtual machine, a live migrate virtual machine from, if there is a hardware failure from one node to another node. It can also spin up the virtual machine, reboot, migrate from one failed node to another node within a data center, and it can also provide the region support as well. You can have a virtual machine available across different regions if in an event of a data center failure. So that's also a very good feature. Azure can also provide access to the on-premises resources as well, obviously with the cost of additional hop, but that's also a very suitable scenario because the organizations still have their resources on premises as well as on the cloud as well. Then it can also allow you to set up a device tunnel and a user tunnel. With the user tunnel, because obviously you would need an NPS server, so you can deploy an NPS server within an Azure, and that will give a better user experience when it comes to authentication. The user traffic will quickly be authenticated from a Azure-based NPS service. So that could also be achieved. And then we have you can use it for hybrid cloud computing requirements. The customer who have a hybrid cloud, they can use the routing and remote access within Azure. Then we have some disadvantages, and one of the disadvantage of having a RAS in Azure is there is no Microsoft support. Microsoft simply don't support this workload, but that's not just one thing. I mean, obviously we can, organization like ourselves, we can help set up the VPN service in the cloud, and we can provide technical support because all our solutions are deployed by our consultants, and we can also provide after-sales support as well. So that's something, obviously, if an organization can forego Microsoft formal support, then that is a very good option to host in Azure cloud. Then it doesn't also provide Windows load balancing native support. So there are some load balancing option available from the Azure marketplace from Microsoft, which also doesn't give all the options which normally you would have with the ADC, like a Kemp or any similar device, which will give you all the health check option and all the load balancing option with advanced features. So these are certain things which would be considered as a disadvantage advantages for having it in the cloud. So we can talk about more, but I will just move on to the advantages of having the RAS on premises. So obviously it's fully supported. It provides access to all the workloads, even the legacy, which cannot be migrated to cloud. So you can have having something on premises mean like you can access all the resources, and also it can also give you access to the Azure based resources. You can have express routes, you can have a point-to-point, point-to-site, or you can have a new feature which is available in Windows Server 2019 Vice Advanced Center. It's called Azure Network Interface. You can connect through this feature, and you can have access to your cloud-based resources. It also supports IPv4 because obviously if you still have legacy applications running with IPv4, they can't support direct access. Then that is still a very suitable use case for having RAS on premises. Then we have obviously it supports Windows load balancing. Also it supports all other features which are available, like a third-party load balancer, GSLP, ADC, Kemp, etc., etc. There are some disadvantages of having RAS on premises, and then obviously there is an upfront infrastructure cost. So the customer has to manage and maintain the physical and the virtual infrastructure on an ongoing basis, which obviously can be with the Azure. You have the Azure is basically taking care of that feature. Then there is no built-in multi-site or Windows load balancing support, which was available in DA if you have a routing and remote access. So you can either use a Windows load balancing or a third-party load balancer or GSLB appliance to achieve this feature. Again, this is still a single point of failure. If you just only deploy one server on one premises, then it is still a single point of failure unless you have a highly available pair, or you can basically use any third-party GSLB solution. So these
Fantastic.
are just a few options for hosting routing and remote access on cloud and on premises.
Fantastic. What a comprehensive answer there, Majid. I'm very impressed. Brilliant. Question 2. I use Windows native load balancer for my Always On VPN deployment. Why should I move to Kemp? I think this has your name written all over it, Sid.
Yep. So when we're looking at Windows network load balancing, there are 3 considerations you need to understand. The first is you want to be able to have session persistence. Windows network load balancing don't give that option. The second is you're going to look at the load balancing features themselves. As Majid just mentioned, Windows network load balancing, for example, only gives you basic things such as round robin. You're going to want more complex ways of looking at the server, seeing if it's available to hand over the next connection over, whereas load balancer can do that for you. And thirdly, you want to look at the health checks. How is the load balancer responding? How is the server responding? How is the application responding? The Kemp load balancer is going to give you at least 8 or 9 different ways that you can tell how the application is doing, so you can send traffic to it. So those 3 points right there, the fact that you need better load balancing algorithms, better health checking, and also a better persistence is where Kemp wins in regards to Windows network load balancing, as well as you're going to have a easier time of using it as well, quick to deploy, and it's easy to use.
Fantastic. Thank you, Sid. Next question. How do you effectively transition from an existing VPN to Always On VPN? Majid, I think we've earmarked you to answer this one.
Okay, thanks for that. Right, so when it comes to migrating from an existing VPN, which is, again, there are different types of VPNs. Cisco could be one of them, or you can have all different vendors do provide IPv4 VPN. So the best thing would be to set up a parallel Always On VPN setup, have the Windows server, which is a server side setup. Have obviously you would have to discuss all the customer requirements, because when it comes to Always On VPN, there are 2 types of tunnels. One is a device tunnel and a user tunnel. So there will be a scoping call, and you will go through all the customer requirements. Once you have the customer requirements and number of tunnels required, and then number of types of authentication required, etc., then you will have a parallel setup. Once the parallel setup has been set up, you will test the initial access. If all the issues been resolved, then you will start, either you disable that feature, the existing VPN feature, which could be a small application installed on the endpoint. You just literally remove that, but before you remove that, you make sure you have provision the Always On VPN required profile, either device or tunnel, which has been tested. And then once the existing VPN profile has been removed, then the endpoint will be migrated over to the Always On VPN. And obviously on the server side, you can also do the hard switchover or a soft switchover, depending on how you want to migrate.
Fantastic. Thank you very much. Next question. What kind of health checking does load balancing do for VPN servers? Sid, I appreciate you've just kind of touched on this. Would you mind going into a bit more detail?
Yeah, sure, Sam. So when we're looking at Always On VPN, there are two types of health checks which are common that you'll need to be aware of. So if you're doing this via IKE version 2, then you're going to need is a UDP-based protocol, so you're going to have to use a ping. You can also use the binary string to check for a particular string you want to look for. The second one is if you're doing SSTP. So if you're doing that, you're going to need to do HTTPS health checking. So that's where we're going to send a packet across to the server. Server will give us a reply back. You can indicate in the load balancer, say, I'm looking for a 200 status code around that, or you can customize whichever one you want. Normally 200 is the one you want. Once you get that back, then the server will say, okay, right, send me traffic, please, and you send the load balance will then send traffic across. Now, all this is taken care of within our template that we provide on our website. So you can select whether you want to deploy it via IKE version 2 or you want to do it by SSTP. The presets are done for you, so you don't even have to think about it.
Fantastic. Thank you, Sid. Next question. We're currently on direct access. What is the best practice to migrate to Always On VPN? Majid.
Okay, so
I feel like we're picking on you here a little bit, Majid. But
so this is a very common use case where all the organization already have direct access and they want to migrate to Always On VPN. So the good news is that Always On VPN and direct access can be hosted side by side. The organization can still have Always On VPN and direct access within their infrastructure. That's fine. So what will happen normally, again, the Always On VPN setup needs to be commissioned within the customer network. That would be separate because that's what we normally suggest, not having it tied down with the direct access on top of direct access. It can be enabled, it's technically possible, but we normally don't suggest that. Because obviously the direct access is still infrastructure dependent, it's still rely on AD, so anything would still be a matter of just making sure that the group policy is applied correctly, and that could also sometimes hinder and prevent Always On VPN functionality. So a separate Always On VPN setup will be set up, will be provisioned within the network, and then initial testing will be performed. Once the initial testing has been done, then the endpoint, which is a Windows 10, I believe, because that's the minimum required. Then it's group membership, through which it gets the settings for the direct access will be removed. So once its group membership's been removed, then obviously the group settings for direct access will also be removed on the next reboot, and then the device will left with a device or user tunnel, depending on how you provisioned it, and that's mean the endpoint has been migrated over from direct access to VPN, and then you can decommission your existing DS servers, obviously following the best practice and making sure you remove every bit, like DNS records, a group policy, etc., etc.
Okay, fantastic. Thank you. Next one is one for you as well, Majid. What are the dangers of split tunneling, and how can this be mitigated?
Right, that's a good question, and so we need to understand the split tunneling is basically where you have a VPN. Once the VPN is established, the corporate traffic or the traffic which you would want to travel at the VPN tunnel will only go via the VPN route. All other traffic, which means it will still go direct. Now there is a danger. The endpoint will be exposed if it goes to the internet, and because normally what happens if it's a corporate managed device, then you would normally want to monitor all the activity and all the resources being accessed from the endpoint. So there could be a compliance reason. There could be, obviously, you want to make sure the device is not infected with any malware or with any other thing which could also have have an impact on within your corporate network. So that is the main issue with the split tunneling, that when you enable split tunneling, you don't have access to what traffic is basically bypassing and where the user is directly going to the internet. Now, there are options available through which obviously you can have a third-party cloud-based solution, like you can have a Microsoft ATV Defender that provides web content filtering. You can have a Cisco Umbrella, which is an open DNS based. We can also provide a Web Titan, which is a solution, a similar open DNS based solution, which provide content filtering. So all these things can be achieved. There are other ways of achieving certain things, because obviously if you are subject to NCSC guidelines and you want to have a managed tunnel means you only allow certain traffic. By default, if you have a Windows firewall, the Windows firewall default behavior is it will allow everything outbound, but it will not accept anything inbound. So you can have the public and private profile locked down, and you can only allow access to certain resources. Even we have certain customers where they are using selective tunnel. Selective tunnel is where basically you have a forced tunnel with some exceptions. You can have some exceptions, like for because Microsoft is recommending that you should have Office 365 Direct. So you can have exception added. So that means there are certain use cases if split tunneling is not an best option. We can reduce the danger of exposing the endpoint by having certain options available and securing the endpoint.
Fantastic, great answer. Sid, next question. I've seen this come in from quite a few people over the last few weeks, and I've kind of consolidated the different questions down. If I'm using Ike version 2 for Always On VPN, how can I load balance that?
Right. So one of the things with Always On VPN is that you have two different ports which you need to go to the same server, port 500 and 4500. The problem is Microsoft mentioned that you're going to need a solution to help funnel all that in. So what Kemp do is we have a port following feature. So in the template that I mentioned earlier, you have the 500 and 4500 virtual service, and you allow port following so that you don't have to keep logging in. So effectively, both ports will speak to each other and then heading over to the same server. What you don't want to happen is 500 to go to one server, 4500 to the other one, because the connections will drop. So we at Kemp solve that problem for you by using our technology to stream both ports into the same connection, going to the same server.
Okay, brilliant. Thanks for that, Sid.
Mm-hmm.
With Direct Access VPN, you can manage/access devices remotely as if on the same network for support. Can this be done with Always On VPN, Majid?
Can you just go back to the question again? I didn't.
Of course, sorry. With Direct Access VPN, you can manage/access devices remotely, as if on the same network for support. Can this be done with Always On VPN?
Yes. Okay, so this is something within a direct access. There's something called manage out. That was a feature through which you can basically remotely manage the direct access endpoints. And obviously, there were certain requirements. You have to have IPv6 return route to achieve that functionality. With the Always On VPN, because it's a IPv4 based solution. So yes, this is possible as long as the routing is in place and you allow this type of access. Once the device, again, you would have to, normally the use case would be a device tunnel, because device tunnel, one of the use case for device tunnel is that you want to remotely manage the endpoints and without having a user present at the machine and logged onto the machine and then give you the access. So once you have a device tunnel, the machine can be left unattended, connected on the network, and then all the remote maintenance can be performed.
Brilliant, thank you. Sid, this is another question that we've been asked a few times. I've obviously put this down as geolocation, but people are asking about multi-site. How can I deliver multiple geolocations using Always On VPN via a load balancer?
Okay, so here is where I just need to describe what geo-load balancing is. So geo-load balancing is where we're taking load balancing, but we're doing it via multiple sites, as you just mentioned, Sam. So it's whether it's in a private data center, public DC, or just multiple sites. What we're doing is we're taking the domain name, so the fully qualified domain name, the FQDN, And what we're doing is, instead of the DNS server saying, I'm going to Kemp's Always On VPN solution, for example, saying go here, is now handing that over to the load balancer. And the load balancer is now saying, I'm now deciding which site is closest to you, Mr. Customer, based off of where you are, based off your IP address. So we use that to say, you have coordinates to say you're closer to your Reading office and you want your Manchester one, so I'll send you there. In the event of a failure, then we will then push all the DNS requests over to the Manchester site, and then the Manchester site will take over and do all the connections and such. The quickness in which this happens is key, because with a solution like that, the last thing you want is having to wait such a long time for your connection to go across with VPN. So the Kemp load balancer can fail over between DCs in terms of doing the DNS request failover. Relative time is a ping is relative to whatever the speeds are for everyone, but it's pretty quick. It's the same thing when we're looking at our HA pairs, which we always recommend you deploy when you're doing a solution. The failover time is exactly the same. So with a Kemp solution, you're getting ease of use, you're getting low latency times, quicker response times, and a quicker failover.
Fantastic. Brilliant. Thank you very much for that, Sid. Next one is for you as well, my friend. What benefit does load balancing bring to an always-on VPN solution? Now, I appreciate you've answered quite a few of these already, but do you mind just recapping, please?
Yeah, sure. So with Always On VPN, as Matt just said, there's a lot of different moving parts that you want to take into consideration. You want a solution that's going to make, like I just mentioned just earlier, quick response times. You normally want to wait about 5-10 seconds, if that, to go to a website. You do want to do the same thing with Always On with a VPN solution. You want to pretty much get on there quickly and get on to do your day. You also want the ability that if you have to log out, log back in, the ability for you for something to remember where you were, so you can just go back to it, just like shopping carts you do with Amazon. So if we have the time it takes for you to log on is a lot shorter, your user experience is seamless, you don't even notice anything. And the fact that we can do it via multiple locations, so no matter where you are, you can get to a site and the load balance takes care of the rest for you, then a lot of those different points which you probably haven't considered that you needed are being solved for you. And it's being done all in one solution that we try to make as easy and as quick, convenient to use as possible. Added to that, if we're going to be also deploying a solution, taking into consideration everything that Matt just mentioned, you want to be able to make sure that when you go to the load balancer, that solution is as frictionless as possible. So this is where our template comes in and allows that deployment of the always-on VPN solution to be as seamless and as quick as possible.
Brilliant. I guess ultimately what you're saying there, Sid, is that using a load balancer makes an always-on VPN solution always on.
Definitely. You always want to make sure you have that always-on seamless experience. So coming with Kemp, you're going to have that always-on solution. So your always-on VPN is always on.
I think we should coin that. Brilliant. Does Always-on VPN support IPv4, unlike direct access, which only supports IPv6? Majid, I believe you're going to answer this one.
Yeah. Right. So yes, this is one of the main issue with the direct access, because direct access is only IPv6. So it can only the endpoint and the direct access server only communicate over IPv6 protocol, and then the direct access server does a NAT64 translation, and this is how the corporate resources are accessed. So there are issues where some legacy application, either they cannot use FQDN, they have a pre-configured IPv4 address, so they will fail to initiate the communication over the direct access. And then if you have an application which is not IPv6 aware, like it cannot use the IPv6 address as a source address, then it will fail. So to overcome this problem, you would need an IPv4 based solution. So direct access doesn't provide that. From the client to the server, and then with the Always On VPN, it is a dual stack. So you can either have IPv6 or IPv4, both running side by side. So it's fully IPv4 supported. The endpoint will receive an IPv4 address, and you can track every movement within the corporate network once the device is connected over the VPN tunnel. That what activities the device was doing, how what things what access was he was trying to access, what resources he was trying to access. So that is fully supported solution. So you have an IPv4 tunnel from the source to the destination, and all the devices can communicate back without having to go through any third party. So it will be like you're sitting in your office, and that is a true virtual private network.
Perfect. Thank you, Majid. Another one for you, and I think you touched on this earlier. How can the Always On VPN support manage out? Does this require any additional setup like in direct access where ISA-tap could be used to achieve this?
Yeah, so that's again a little bit more in terms of if there are any special requirements. So with the direct access, yes, this was the requirement. You have to have ISA-tap. Basically, you need IPv6 route from your corporate office to all the direct access server, and then you can basically, the direct access server can route that traffic to the endpoint, and that's how you control or manage out the direct access connected endpoint. With the Always On VPN, there are no additional requirements. As I said, as long as the routing is in place, all the the corporate switches are aware of the remote access VPN range, and they can route traffic via the VPN server the way it came in, like the symmetric way, and then you can manage out all endpoints without any problem.
Brilliant. Perfect. Can Always On VPN be set up as active backup, whereby if the primary tunnel fails, then a backup can be fired up?
Yeah, that is also a very good use case, because obviously with the direct access, the organization was still keeping an IPv4 based VPN, because obviously if the direct access fails for any reason, then obviously they have a backup option to connect to the corporate network. So when it comes to the Always On VPN, we have different types of tunnels, and again, it will depend on the type of use case. With the direct access, there was no customization. You would have to deploy the solution as full, and it will be IP HTTPS wrapper. That is the most common transitioning technology, and then there will be two IPsec tunnels. When it comes to Always On VPN, you have the option to deploy one tunnel, device tunnel, or a user tunnel, or together, or in an active backup fashion. So the issue with the with the device tunnel is it's a UDP base, and it means it could be prevented from certain locations. So if the device tunnel fails for any reasons, then you would have to use a SSTP base, which is a TCP/443, similar to what you see in the direct access. That can also be that can only be available on a user tunnel. So you would have to fire up a user tunnel once the user logged onto the device, and that could be a backup option, or it could be a parallel option. We can deploy the organization. The tunnel can coexist together. There is no problem. Each tunnel is using its own interface, and in order to route the traffic, we can have a first tunnel restricted with only access to the resources like a management servers, DNS, AD, your policy servers, your Windows update servers, etc. And once user logs into the device, then the user tunnel can be fired up again, and that's where you get more access based on the user, like that tunnel will carry more user traffic. So all these scenarios are possible, and we can look into each use case, and we can suggest. But yes, definitely there's always going to be a backup tunnel, because that's what we recommend.
Brilliant. Thank you. And again, I think this one was covered by you earlier, but might just need to reiterate. Can Always On VPN support captive portal?
This is obviously when you are behind a splash screen, or you connecting from a coffee shop or a hotel. They normally have a page where you need to enter some details, and you need to accept some agreement. So Always On VPN don't have a feature through which it can basically detect and provide those credentials. So you will still need to, depending on if it's a corporate issued device, whereby you don't allow anything out other than the VPN, then your device, your Always On VPN will not allow you to access this one. So that will fail. You would have there are certain options available, because there is a chance of exposing your endpoint to an unencrypted Wi-Fi channel, and that means any malicious activity could browse, could steal data held in a browser. So there are certain recommendation from NCSCs whereby there is an app which is available on Windows 10. It's called Captive IP Helper app, which is a sandbox which runs within a sandbox environment, and you can allow through only based on the signature ID of that app. So the Windows firewall on the endpoint will only allow access to that app. So wherever you are, you open that app, that will give you a username and password. It will detect the captive portal and allow you to input your data, and then you are connected, and then it will automatically shut itself down. So that is the one option where you have a corporate device and you normally don't allow any outbound access, and then yes, that can be achieved with this captive portal application. Perfect,
lovely, great. So Sid, one for you here. I use my Citrix Netscaler for Always On VPN as well as my VDI. I'm assuming they've kind of maybe split these, but anyway, can I replace this with Kemp?
The short answer is yes. So recently we've come out with a template that can help load balance Citrix storefront as well. So yeah, the short answer is yes. For a long answer for that, contact Sam and myself, and we'll give you a more in-depth answer to it.
Okay, great stuff. Lee, I'm going to now pick on you for the next few questions.
Yep.
Can Always On VPN replace Citrix and Windows virtual desktop solutions?
Yep. So the short answer to this one is it does depend on the application specifically, but effectively, yes. Always On VPN provides a compressed connection back to the server infrastructure. So most applications nowadays support connections over low bandwidth requirements. So both Citrix and also Windows Virtual Desktop connections and solutions potentially could be replaced with Always On VPN, but obviously there's a certain amount of planning that would be needed to capture those applications, to work out the security requirements and etc., and securely publish them using necessary load balance and also security measures.
Fantastic. Good answer. What are the requirements to service an always-on VPN solution, Lee?
Yep. So always-on VPN solution is predominantly Microsoft-based. Obviously, it requires Windows 10 as well as some basic features like DNS and also your AD and domain authentication services, as well as network policy server, effectively Radius, and certificates for compressed and secure connections back to the Always-on VPN infrastructure. So predominantly those are the key requirements. Obviously you need bandwidth, a secure firewall solution that would provide DDoS and mitigation protection, as well as securely publishing it through necessary load balance solution as well.
Okay, perfect. Thank you. I appreciate you've kind of just answered this one, but what licensing is required to enable Always On VPN?
Yep. So Always On VPN is basically available on Windows 10 predominantly, and also the backend server infrastructure. You'd need necessary licensing to cover the server components there, as well as obviously licensing the elements of load balancing. And potentially any multi-factor authentication services that you would overlay over the top of that.
Okay, great stuff. How do you monitor Always On VPN connections and the end user experience?
Yep, so there are some basic functionality from Microsoft that provide endpoint monitoring. Obviously, you can send back user statistics data. You can actually use some of the endpoint protection mechanisms that are built into Windows 10, as well as any endpoint protection that would be deployed on those devices. But endpoint user experience monitoring would potentially need a third-party overlay, but some of those features that would be basically available from within firewall statistics, from within the load balancing statistics capture, are already available there.
Fantastic. This next question, someone seems keen to get a trial. So can we trial the Always On VPN solution alongside our existing remote access method?
Yes, absolutely. So the Always On VPN solution could be trialed and implemented with just running through the necessary design captures, making sure we got the necessary connectivity, the compute, and basic components available to meet the Always On VPN requirements. But absolutely, trials are available in terms of the necessary licensing as well. So that can be easily implemented, as well as overlaying with the likes of Kemp for a trial license as well for load balancing.
Oh, definitely. Just a question for my benefit. How long would an Always On VPN trial? How long would that be? You know, Kemp, we obviously offer a 30-day trial. Is it similar timeframes?
In terms of trialing the actual service, I would suggest a 30-day trial would be sufficient. Microsoft do provide 180-day availability licensing, and then potentially further if needed. But 30 days would provide a sufficient time frame to trial that.
Brilliant. I know you've just mentioned it, but can MFA be implemented to protect Always On VPN authentication?
Yep. So as Majid answered earlier, there's various different tunnels, VPN tunnels, and availability within the Always On VPN solution. So to ensure MFA can be used to protect Always On VPN, it would only be available on the user tunnel, and then basically the MFA conditional elements, whether they deliver a text message token, whether you've got a passphrase or integration to any other third-party one-time press authentication, that can then be obviously implemented. But MFA is only available on the user tunnel.
Okay, perfect. Thanks, Lee. And this last question is open to all three of you, if everyone wants to take a crack. At what point does the VPN connect? Does Always On mean it's connected during boot up or as a user logs on? Lee, if you want to answer that first.
So obviously, when you're logging into, when you effectively open up a Windows 10 operating system or boot into the operating system, behind the scenes, the VPN goes through certain states. Effectively, it tries to establish a connection back into the infrastructure. There used to be something called SBL, Start Before Logon. And also MDA provided the ability to establish that using certificate exchange. It basically provides the user side would provide authentication at the user point, creating a secure tunnel back into the infrastructure when the user's credentials are securely exchanged to the back-end infrastructure. So effectively, it's at logon. Majid, I'm not sure if you've got anything else to add to that one there.
Yeah, so as Lee just explained, so Always On means the tunnel type can be made to become an Always On mean that whenever depending on the tunnel, the device tunnel or the user tunnel, both can be set to both Always On VPN. The device tunnel will try to connect right after the boot when the networking stack is loaded and the device has an internet access, and the NCSE probe becomes successful because Microsoft uses NCSE to determine if the application if it's a suitable time to connect, other than just applications keep trying to connect and there is no connection. So NCSE probe will help determine to help make that decision by the VPN plugin, and then there will be the same use case for the user side as well. When the user logs onto the device, and if there is a device tunnel provision under the user profile to kick in at the same time, then it will be initiated at the same time.
Okay, fantastic. Thank you very much for that, guys. Before we finish up, We've answered all the questions that came in prior to the webinar or the Q&A session. We've actually had a fair few come in whilst we've been chatting. So I'm just going to run through a few of these. This is open to all three of you. So, you know, if whoever wants to take it, please just raise your hand or say, I'll take this. Everyone can interject. I just appreciate when everyone's talking at the same time, it sometimes can't be heard. So I think the first two, I imagine, Lee, you'll probably want to take these. So I'll pose these to you first. Lee, what applications support Always On VPN?
Okay, so most applications will be able to support Always On VPN. Obviously, vendors have, or software manufacturers have a certain requirements in terms of bandwidth. Some of those lend themselves better to a terminal server environment, but majority of actual applications can be securely wrapped, securely connected, and established over an always-on VPN compressed connection. So long and short of it is most applications will support always-on VPN, and obviously most applications, or all applications from Microsoft will be able to support it.
Fantastic. Has anyone else got anything to add there?
No, that's fine. I think the application support is always on VPN support all types of applications. So again, we would have to look into it if there is a use case. But as I said, it allows you to give a path, so you can basically communicate over a path. It's an IPv4 path, and you can basically communicate over it.
Yeah, perfect. Lee, again, this is another question that's just come in, so we'll answer it as we want to answer most of these. There are quite a few, so. What would you recommend to securely publish Always On VPN externally?
Okay, I think we kind of covered some of this one earlier, but effectively, same rules apply in terms of publishing any application. To make sure that application is secure, we put the necessary NAT protocols in place. We put an enterprise grade or a secure necessary firewall wrap around that, protecting DDoS or any mitigation or potential unauthorized access from the outside world in. The necessary multi-factor authentication would overlay over the top of it, providing things like conditional access as well, where we can actually work out where that connection is coming from and apply different policies. Certificate exchange and obviously strong password authentication is still part of obviously the cybersecurity recommendations, and then obviously any other logon or multi-factor overlay over the top would be recommended.
Okay, fantastic, thank you. Okay, again, next question is open to everyone. We're hosted in Azure. Devices are managed by Intune. What is the recommended method to set up? And we can can we have both server 2016 roles on one server? Who would like to pick that up?
If it's in the context of having a RAS feature, then as I've explained, that other than the Microsoft support, it is a very good use case, and this can be achieved. Again, I'm not sure about having both server 2016. I mean, we would normally recommend having a 2019 virtual machine, because all the new feature sets and all the development Microsoft is doing, they are adding into server 2019. For example, Microsoft has Windows 10 support IKEV version 2 fragmentation. That support Microsoft has only added in server 2019. Microsoft has disabled the TLS 1.2 dependency used by the reporting only in 2019. Even on 2016, you still, if you want to disable TLS 1.0, the Windows reporting, the internal database will cease to function. Then you have the CRL check, which is available. Excuse me. The CRL checking for the device tunnel certificate is also available in 2019 and 16. So if you're looking for in terms of a future-proof technology, then you should be going for a server 2019. And again, yes, we can have if we can even have an NPS role on a VPN server, but depending on if it's a customer with like 1,000 connections or more than that, then we would normally suggest not to overload the server with multiple services, which will be still a single point of failure. So we should just distribute the load across servers to get a better user experience.
Brilliant. Thank you very much. There is a question here specifically about Kemp, but what we'll do is, Sid, I'll ask you to reach out on this one specifically and touch base directly on that. Okay, next question. Are you limited to Microsoft NPS server for radius authentication? That's open to everyone, guys.
Again, I mean, we would normally suggest using the Microsoft, because it's the Microsoft solution and the Microsoft Radius the NPS server works very well. However, it's open standard. The Microsoft support the Radius, even the Radius implementation support PEEP and all other PEEP types. So yes, if you have a third-party solution which can accept, because normally the Radius would be used for EAP TLS, and if it support EAP TLS and the PEEP outer and inner, then yes, it can be achieved. But as I said, from our experience, that the Microsoft NPS work quite very well.
Yeah, and obviously that's included within the license set as well from Microsoft, so there's some benefits there without adding additional cost.
Brilliant. So last two, whilst we're reading these out, if there are any other questions, guys, feel free to send them in. So what are the cost calculations for this VPN solution?
I think it's a good question. It's a fairly open question. It depends on the size of the environment, number of users you've got available there. Obviously, you need the relevant Microsoft licensing for those, and the relevant size load balancer, and also certificate backend infrastructure. Also, depending on whether you're running on-premise, there'll obviously be virtualization costs potentially, as well as if it's running within the cloud or Azure. You obviously got Azure compute and storage, egress and ingress, egress charges, as well as any other costs in terms of connectivity and getting your users into that environment. So it's on a per solution basis, and obviously that would need to be factored in terms of sizing up the environment and putting the Always On VPN solution forward.
Good answer. I think that's certainly something we can, touch base with whoever asked that question and start working on. Okay, next question. What's the biggest advantages from OpenVPN versus Global Protect? That's open to anyone.
Because obviously we are here for Always On VPN. I mean, that can be, we would have to just review both, because obviously I personally don't have much experience with these technologies, so really it will be difficult to just compare right now. So we can answer this after the call if that's the case. But obviously, yeah, these are the two different technologies. They will have their pros and cons, and we can evaluate that.
Okay, perfect. Thank you for that. And last question. We have experienced issues with NAT.
External.
Yeah, port exhaustion on direct access. This is still going. Is this still going to be an issue on Always On VPN? So let me repeat that. I think we're right here. We have experienced issues with NAT external port exhaustion on direct access. Is this going to be an issue in Always On VPN?
Assuming they've run out of necessary ports to get back into the environment there.
Yeah, I think I can answer that. So with the direct access, because the fact it does the NAT translation 6 to 4, that there is I think limited ports which Microsoft allow per network, because there is only one. If it's a dual NIC topology, it will only allow net translation on the inside leg. If it's a single NIC, then it will be just a single NIC. So what happens when a direct access connection is connected, and then you start accessing resources, internal resources? For every resource, the direct access server does a NAT 624 translation. It maintains a NAT table, and within that NAT table, it has limited ports to translate. And then obviously, if with the environments where you're making like more than 40,000 connection or translation, then you will have port exhaustion issues, and that's only because of the 624 translation. With Always On VPN, there is no translation. The device is making a direct connection to the resource. The VPN server is just literally acting as a concentrator. It just accept the connection, terminate the connection, decrypt the connection, and then forward as a decrypt.
Fantastic.
That problem can be solved with Always On VPN as well.
Yeah. Perfect. Okay, guys. I just want to say a massive thank you to the three of you for coming on, and thank you to everyone that's attended. We'll be wrapping up now. If there are any other questions that you would like answering by the three specialists or myself, not that I've answered any, please feel free to get in contact with us. We'll be sending out a recording of this to all the attendees afterwards as well, with everyone's details on, to make sure you've got the contact in the right places. Lovely. Thank you very much, all. Have a great rest of the day.
Thank you. Bye.
Bye.